Hello, my name is Maritza Valdez, representing Group 9. My group members were Pedro, Gerron, and Carlos. We chose 3 trees for this presentation in between the Science Building and the Tutoring Center, labeling those trees A, B, and C. We all went out there and took the measurements of the length, the distance between A, B, B, C, and AC, giving us side lengths A, B, and C. We also took the heights of the trees using our hands to match up our hands to the length of the trees in a distance, and then we used one eye to calculate the top of the tree to the tip of our finger and the base of the tree to the bottom of our hands, and lowered our hands this way and placed another student over here, and then measured the distance of that between the students and the tree so that we can take the height. We look at the base, and that is where we put the bottom of our hand, and our thumb, the tip of our thumb, has to match the tip of the tree. So we put it at the base like this, and then calculate to the top of the tree. To make sure that we're getting it right at the height, we just move back. Okay, let's say that that's the correct height. We move back to make sure that's the height, and then we bring our hand down, and at the tip of my finger is where we put another student so that we can measure the distance from where that student was at all the way through the base, and that distance was the height of the tree. Using those measurements of the side lengths, we were able to calculate the area, parameter, angles of the triangle we formed with our tree. For the area, we used the Gerron's formula, giving us the area of 60,886.20 inches. And for the perimeter, all we did was add side lengths A, B, and C to give us 98.25 feet. For the angles, we did use law of cosines first, so that we made calculate for angle alpha, and we then switched to law of sines to measure angle beta. Once we calculated those two angles, we were able to calculate angle gamma by adding alpha and beta together and subtracting those numbers from 180, because all the angles together will give us a total of 180, so that we can gather the total for gamma, giving us 5570 for gamma, beta was 83.65, and alpha was 40.70. Here I will show you the triangle that our tree formed. It was about approximately this shape. Side length A was 311, side length B was 474, and side length C was 394 inches. We used those lengths mainly for the area using the Gerron's formula. This is our calculations for the Gerron's formula. Gerron's formula is the area of square root of S times S minus A times S minus B times S minus C. Of course, S is equal to 1 over 2 times A plus B plus C. Of course, our A is 311, C is 394, and B is 474. This is the side lengths that they represent, the points that they represent. We calculated those numbers and we got the total right here in inches, 60,886.20, and in feet it was 5,073.85. For parameter, of course, we did the A plus B plus C, which was 1,179 inches, or 98.25 feet. For the angles of the triangle, like I said, we used the law of cosines. Here is our calculations. It is pretty lengthy, but our alpha was 40.70. And for beta, we switched over to law of sines. Law of sine is sine beta over side length B, which is equal to sine of alpha over side length A. Our lengths were 474 for B, 311 for A, and of course our sine of alpha is sine 40.70, and beta turned out to be 83.65. We added those together, 83.65, 40.70, minus 180, so that we can get gamma, which was 55.70, giving us these side lengths. That was the conclusion for our triangle that we formed with our trees, tree A, B, and C. And that was our presentation. Thank you.